Hello everyone. In this video we're going to discuss about apparent weightlessness. So apparent weightlessness. Before we dig into the topic, I hope you already knew what is the difference between mass and weight. We all know that weight is equals to mass times gravity. Without gravity, you will be weightless. And any object on the universe actually has mass. Mass can be anywhere in our solar system, in the universe, and it is actually constant. The weight varies on planetary object. So, for example, the gravity of Earth is 9.81 and the gravity of the moon is around 1.6. So the gravity varies. So therefore, the weight varies also because of the formula of weight, which is equals to mass times gravity. So apparent weightlessness occurs when you are under strong influence of a large body, but we're also experiencing acceleration of an equal and opposite direction, and that is basically cancelled out gravitational acceleration that made you feel weightless. So apparent weightlessness is actually the feeling of being weightless. The opposite of apparent weightlessness is actually true weightlessness. A true weightlessness is having no gravity on it. So there is no gravity present in a true weightlessness. On the other hand, apparent weightlessness, it has actually a gravity. You just feel, you just felt being weightless because of the sensation and the effect. So that's the feel of having weightless. So there are actually events on which makes you feel weightless. First one would be jumps upward off a trampoline. So we have a video here. So when you jump up and down in a trampoline, you can actually feel weightless in a few seconds or milliseconds, depending on how high you jump. So this is actually a feeling of having no weight at all. Second one is treads on a non-existent floor in the dark. So suppose if you have experienced this, I had actually experienced this when I walk in a dark room and I know in my mind that there is a stair on it, but apparently I miscalculated the stairs, and like when I step ahead, I feel like I am stepping on the stairs, but the feeling of having no weight actually occurs when you step on it and there is no stairs. So that's actually one feeling of having no weight at all. The third one is when you travel on an airplane that hits an air pocket. And an example for this is actually a zero gravity or zero G plane, and it is also known as the vomit comet. So let's just watch a video about a vomit comet here.
The principle behind weightlessness is pretty simple. The plane and everything inside it just need to accelerate towards the Earth at the same rate as a freely falling object in a vacuum, that is 9.8 meters per second squared. So you can think of your body as this pen and the plane as this bottle, and when it's freely falling, There's no contact force between the pen and the bottle, and so the pen feels weightless. So you might think the way to do this is just to put the plane into a dive, but that's not actually how it works. Instead, the plane starts climbing at a steadily increasing angle. With no windows inside, it's impossible to tell that this is happening, and all you feel is pressed into the floor with a force 1.8 times your body weight. This is because the plane's acceleration is directed upwards and perpendicular to the floor, and it makes standing very difficult. Not only are you nearly twice as heavy, all the blood drains from your head and into your feet, which made me pretty dizzy.
So weak!
Lying on your back is much more comfortable, and we're advised not to move our heads around and look straight ahead, because in hyperg, our vestibular system is hypersensitive to movement, which can lead to motion sickness. And that's why this is sometimes called the vomit comet.
I kind of like this.
It is fun. Feels like someone lying on you.
Yeah.
And I like that.
Yeah.
Once the plane is climbing at about 50 degrees, the engines are ramped down and the plane is put into a parabolic trajectory. It's at this point that you start experiencing weightlessness.
I can feel myself getting lighter. Whoa, that is such a strange feeling. That is so weird.
The plane and you are still moving upward, but you are accelerating downward.
There's Diana. She's the physics girl.
Then the
Oh
plane
my
peaks
goodness.
and starts speeding up again towards the Earth.
This is totally strange.
The whole time, the plane is accelerating toward Earth with the same acceleration as a free-falling object in vacuum. The pilots have to very skillfully adjust the thrust to perfectly balance air resistance and maintain exactly this acceleration.
Okay.
Oh my goodness. How do you feel?
It's incredible.
So it's like throwing this bottle into the air. The pen inside experiences weightlessness from the time it leaves my hand until it comes into contact again. After 22 seconds of weightlessness, the pilots pull out of the dive, again subjecting us to hyperg as the plane accelerates upwards. In total, we performed 13 of these zero-G parabolas, plus 1 Martian gravity and 2 moon gravity parabolas.
Okay, we are now in Mars gravity. In Mars gravity, I can do one-arm pull-ups, maybe.
Push-ups, one out. Push-ups like this. Yeah, like this. Wow. One out, one out.
I am the Martian.
Alright, so this is how it feels being a weightless in an apparent weightlessness. So it's kind of fun. This is called the vomit comet because yeah, if you ride in this plane and you're a bit seasick, you could eventually throw up in this plane. The fourth one is at space station. We all know that astronauts in space station feels like they are floating. So this is the reason why they feel the apparent weightlessness.
Have you wondered what it would be like to be an astronaut floating around in the space station?
But why are the astronauts floating? I'm here at the Powerhouse Museum in Sydney to find out if anyone knows the answer. Why are they floating?
No gravity.
No gravity.
Zero gravity.
There's no gravity.
The stuff that holds us to the planet when we spin doesn't happen up there.
Gravity holds you down, so in space there's nothing there, so you just float.
There's no gravity in space.
No gravity, or there's very little.
But is there really no gravity in space? After all, the moon orbits the Earth due to gravitational attraction. So, where would the space station fit in this picture?
Can you make me a roughly to scale model of the Earth and the moon? And then we're going to position the space station in there. So about like that?
Yeah.
About there?
Closer, maybe. About there. About that.
Are you ready to see the real distance? What do you reckon?
Oh, okay.
It's actually about here, maybe a little further.
I think we were wrong.
Now, if the moon is here and the Earth is there, whereabouts would you put the space station?
Somewhere around here.
Further here?
Midway.
About halfway?
Yeah.
Right about here? So that's maybe like a quarter of the distance to the moon. Let me show you the real distance. Are you ready for the real distance? The space station is right about there.
That close.
Oh, okay,
Right there.
that close.
Wow.
We're not good at this game.
the space station is actually only about 400 kilometers away. So if you're in Sydney, it's a little further than the drive to Canberra.
But does it make sense that the Earth exerts a big gravitational force on you, but nothing on the astronauts just a short distance away? You reckon there'd be no gravity there?
There's not much. They float. We've seen them.
Well, clearly there's not. They're floating around.
I know they float. And the question is why?
No idea. I'm really confused.
Well, in truth, the force on the astronauts is almost as much as the force on you. So then, why are they floating while you're stuck here?
The answer is the astronauts aren't floating, they're falling. Ah! And not only that, but the space station they're in is falling as well. Ah! So why doesn't the space station come crashing into the Earth? Well, the reason is the space station and astronauts inside have this huge sideways velocity of about 28,000 kilometers per hour. So even though they're falling towards the Earth, they're going so fast that as they fall towards the Earth's surface, it curves away from them.
If the Earth didn't put a gravitational force on them, they would fly out into space.
Sure, yeah.
Right? So it's due to that gravitational pull that they can actually keep orbiting the Earth.
If it was to stop moving, it would be plummeting.
Exactly.
But would they...
They would still feel weightless until you smash into something.
Okay.
So the space station and the astronauts inside are constantly accelerating towards the Earth's core, but they never get any closer. And because they're accelerating at the same rate, the astronauts feel weightless. They have this amazing sensation of floating.
Okay, so that's the reason why astronauts feels the apparent weightlessness. Okay, take note, it's apparent because there is still gravity on space station. But the amount of gravity in space station is about 90% of the gravitational amount that we have. So 9.81 times the 90%, so that's the amount of gravitational pull that the space station is attracted to. Okay. So to calculate the time at which you feel weightless. So the formula is time equals to the square root of 2 times the height over the gravity. So for example, you're jumping or diving off a 10-meter board. Okay, so the height here is 10 meters. Sorry, should put an S here. 10 meters. And then to calculate the time, we just need to substitute the values here. So the height is 10 meters. And the gravity, of course, of the Earth is 9.81. That will give us the apparent weightlessness that you're going to feel is just around 1.4 seconds. Alright, so that sums up the discussion about apparent weightlessness. So again, the difference between apparent weightlessness and true weightlessness is the presence of gravity. The true weightlessness doesn't have any gravity. So space station is just above the Earth. The Earth crosses about 400 kilometers, so it's just too near. Okay, so if you have any more questions, just leave a comment below or message me, and I hope you have learned something in our discussion.